வணக்கம் நண்பர்களே. இன்னைக்கு நம்ம பார்க்க போகிறது distillation. Distillation is very important topic. So it's a broad topic. So we are going to see only what is distillation, what are the types, and what is the difference between each of it. So that's what we are going to see. So when you talk about distillation, so it is nothing but we are having a mixture of substance, right? Like ethanol and water. Okay. So separating these components, we can separate it based on the boiling points. So ethanol is having some boiling point, water is having 100 degrees as a boiling point. So based on this, we can separate. But when you go for separation, there will be much more difference between each components. So based on its properties. So the separation, just write it down. Separation of components. I just mentioned only two components. You may have number of components like toluene plus xylene plus water, like that. So separating each component based on its boiling point. So based on its property, each component is having its boiling point. Several components based on the boiling points, you can say, or based on its relative volatility. Similar only. Okay. So when we talk about this, the relative volatility is nothing but vapor pressure. It denotes the vapor pressure of gaseous phase to the liquid phase. Same vapor pressure is related to the gas phase to liquid phase. So that's what is called relative volatility. Okay, we saw the distillation. So what are the types of distillation and where it can use, how it is used? Okay, then you go for types. We call simple distillation. The first type is simple distillation. The next one is the general term. Next is steam distillation. Okay guys, the third one is, we call this as Isotropy distillation. I'll explain you one by one. The next one is extractive distillation. Extractive distillation. The next one is you can say fractional distillation. This is what happens in refinery. The next one is vacuum distillation. So these are the general types. Okay. Similarly, based on the number of components, you can say if you are using only two components, like as I said before, ethanol and water, or acetone and water, only two components, you can call it as binary distillation, right? So more than two components, if it is more than two, plus one like that. If it is more than two, then you can call it as multi-component distillation. Okay. So based on the number of components also, the name varies, but the general terms are this one: simple, steam, isotropic, extractive, and fractional and vacuum distillation. Okay. Now we will see one by one. When you go for simple distillation, when the boiling point, we have a mixture. For example, we have a mixture of the same one, we can take it as acetone and water. You are having acetone plus water. You are having the boiling point difference, not the boiling point. The boiling point difference between the two components is very high. Then you can go for simple distillation. So, for example, for acetone, it is 57 degrees Celsius at an atmospheric pressure, and for water, it is 100, as I know that. So, with the difference, delta T is around 43 degrees Celsius. Like this, you are having more delta T, then you can go for simple distillation. Like just like increase the temperature through a heater or through a boiler in laboratory wise. So you can get the distillate as acetone, and the residue will be water. You can do this. And the next thing is steam distillation. So steam distillation, when you go for steam, it is more temperature. Where you can go for this one, for example, right. To go technically, you are having a mixture along with non-volatile impurity. So, as the name itself, I mentioned non-volatile impurity. So it cannot be vaporized easily. So you are having another component which is volatile. So if you want to remove that volatile component as a distillate, you can use steam distillation. By using steam, the impurities will store here. The low volatile component will try to get as a distillate. Okay, this is volatile compound. And this is non-volatile impurity. Right? So if that is the case, you can go for steam distillation. The next thing, extractive distillation. Okay, we have seen simple. Now extractive distillation. So the name itself, you can see extractive. We are going to extract one component from another component. So this case will be used when the boiling point difference. The boiling point difference is very low. So we can say some examples. So if you take this example, toluene and isooctane. Just take toluene. So all these data are general data. So you not worry yet. Toluene is having around boiling point of 111 degrees Celsius, and isooctane is around 100 degrees Celsius, like water only. So if this is the case, so you can go for extractive. Delta T we have is only 11 degrees Celsius. So what is extractive? So you want to remove, you cannot, there will be more separation issues if you go for other type, simple or steam distillation. So if this is the case, we have to separate one component from other, or you have to change the boiling point difference. How can you do that? We are adding a solvent, additional component. So for this case, we are adding phenol, so which is having the boiling point of around 182 degrees Celsius. So what this phenol is doing? The phenol is dissolving with toluene, and what happens? This will change the boiling point. Means it is either increasing or decreasing. This will increase because this boiling point is 182, this 110. Basically, it will increase only. So it will be around some. Can take the average. Now the isooctane, which will be distilled out. Okay, so this will be distillate. The low boiling component will easily evaporate. So the isooctane will be removed as a distillate, and then it will remain as residue at the bottom. So this will again further fractionator, separator, or distill. In another, you can do again simple distillation also. So by doing that, you can remove phenol and toluene. So for this case, we have to remember one thing: the solvent. The third compound solvent is added. The solvent will dissolve one component and freeze the other component easily. Okay, guys. So this will not affect any component. It will just act as a solvent. The next one is isotropic distillation. So isotropic, this also will be used when the boiling point difference is low. When it is very close, we have to go for extractive distillation only. If it is low, the delta T is low, we can go for isotropic distillation, which is like take acetic acid is having 1.5 degrees Celsius and water is 100 degrees Celsius. If this is the case, for the isotropic, we call it as we are adding. We are just giving. We are adding a component, but we call it here as entrainer. The name changes. So I will tell you the difference between both. Why it is called entrainer, why that is called solvent. By the name itself, we could know that is solvent. So this entrainer, what we are adding here is butyl acetate. For this component, butyl acetate, these entrainers will be selected based on the properties of each component, right? So the adding entrainer should not affect anything. It should only positivate and have to remove one component or change the properties of any one of the component, right? So entrainer, what this entrainer will do. So it is having the boiling point of around 90 degrees Celsius. So this entrainer and water, this will form a new boiling isotope. It forms an isotope. So this isotope is having different boiling point. So the boiling point, it changes. The total mixture, a new boiling point arrives for this mixture, and particularly with water with butyl acetate. But the acetic acid boiling point remains constant. And here, for this case, the acetic acid, which is having high boiling point, it remains as residue for this case, and this isotope will be removed as distillate. Okay, guys, you can see the difference. Here the isotope is distilled out, it is changing the boiling point, but for the last extractive distillation case, it will not change the boiling point, it only dissolves a component by separating from the other component, right? So it is not changing the boiling point there, it is only changing, but here it is changing the boiling point of the mix by forming a mixture, and this isotope is distilled out. For the last case, the solvent remains constant, only the other component is distilled out, right? So that's the difference between both the extractive and isotope, don't be confused with them. And the next thing is fractional distillation. So I don't really say much about fractional distillation. That's what happens in refinery, as I told you. The best example for fractional distillation is crude oil refining, which is happening in refinery. Or you can say it is a multi-component distillation. Like this. So, refinery, we have a column, we are passing crude oil. So we are having trays and packings, right? And we are getting multiple products, LPG, naphtha, kerosene, gasoline, diesel, like that. We are having multiple components based on the boiling points. Each is having a different one, like 100 keeps on increasing up to 350 degrees Celsius, around 300, like that. So this is the best example for crude oil refining is the fractional distillation one. The next thing is the vacuum distillation. The fractional distillation is only it is also called atmospheric distillation. Okay, here the pressure maintains atmosphere near to atmosphere, that's why we call it as atmospheric distillation. The next thing is vacuum distillation. Vacuum distillation, by the name itself we can come to know, here the pressure remains vacuum under below atmospheric pressure. Okay, so that is the main difference between. For example, you can say in laboratories most of the fellows will do dimethyl sulfonate separation. So for this case, the general boiling point is 189 degrees Celsius. But when you process the purification of dimethyl sulfide, the boiling point reduces to around 79 degrees Celsius. So to save for saving fuel and also to avoid thermal decomposition and all, or cracking may happen if it go for high temperature. Mostly in the case of hydrocarbons, we can go for vacuum distillation, right guys? So we don't want to change the property of the product due to thermal cracking. To avoid that, we are selecting the type of distillation we have to use. Okay guys, thank you. That's not for today.